All right. So, oh, sorry, three examples. So here's one where we're not solving for the specific solutions, but we want to find the number of solutions or the number of points of intersection between the systems, okay? So if you look here, everyone sees my screen, right? Yeah, okay, cool. So if you see POI here, wrong color. That's just short form for point of intersection. All right. So again, we just want to figure out the number of solutions or the number of points of intersection, right? So remember, this just means solutions. So what I'm going to do is I'm going to set it up exactly the same way we've set up every other question. Just I'm going to use the discriminant once I have my new function after I make them equal to each other and kind of clean them up, right? So if we look, right, so we're going to make f of x equal to g of x. All right, so I have 3x squared plus 12x plus 14 equals 2x minus 8. So again, the process right now is the same. Now I'm going to move the pieces of g of x onto the other side where f of x is. So I have 3x squared plus 12x minus 2x, because this 2 is positive, it's going to be minus on the other side. And then plus 14, and this minus 8 becomes plus 8. And this all equals 0. All right. And then just like before, right, these I can add together, and these I can add together. Well, sorry, this one's subtract, actually. So I'm going to have 3x squared, 12 x's take away 2 x's is going to be 10 x's. And then 14 plus 8 is going to be 22. All right. So now I have, I've essentially put g of x with f of x together for this new equation. Okay, so now at this point, remember, do not solve, because we're not asked to find the points of intersection, okay? This question just wants us to figure out the number of points of intersection. So here, we will use the discriminant. All right. And if you're thinking, like, well, man, why are we using the discriminant? Well, remember, the discriminant, right, if b squared minus 4ac, right, if it was bigger than 0, then we knew we have 2 solutions, right? If the discriminant was less than 0, then we know there are no solutions. And if the discriminant equaled 0, then there was 1 solution. Okay? So literally, we're just going to use the function up here, the new one that we have from simplifying f of x equals g of x. Use a, b, and c in the discriminant. And then, if it's positive, then I know there are 2 solutions or 2 points of intersection. If it's negative, then there are none. And if it's equal to 0, then there's 1. All right, so I'm just going to write this. So a is 3, b is 10, c is 22. All right, so if we do that, b squared minus 4ac equals, so 10 and then 3 and 22. This is going to be 100 minus, so let's see, this is going to be 66 times 4, right? So 66 times 4, well, 60 times 4 is 240. And then 4 times 6 is 24, so 240, so 264. And then 100 minus 264 is going to be negative 164, okay? So this is negative, all right? So that means that, I'm going to zoom up quick, so close your eyes if this is going to make you feel nauseous. There we go. The number of points of intersection between these two equations, right? So that means there's no point of intersections, okay? All right. Everybody cool with that? Sure. Again, this is, I mean, similar. We did that. We did some of that before, right? When we were looking at solutions. So now let's look at two kind of application style questions with this. All right. So I'll give you a sec just to write this one down. So we want to determine the value of k such that g of x equals 3x plus k intersects f of x at exactly 1 point. Okay. So lots of stuff there. New letters, which generally sometimes freak students out. But like, don't freak out, right? So I have some k. So this is an unknown, right? So here k is the unknown, okay? Which means we gotta figure it out. Now again, you need to just, you have all the knowledge in your brain to answer this. Generally, when we introduce new letters in mathematics, that creates a higher level of anxiety. I don't have any proof of that, I'm just kind of making a general assumption. But take a deep breath and don't get freaked out by letters. So let's just dissect this question a bit more, right? So I have two, I'm just going to kind of jot some stuff down. Okay, so I have f of x equals 2x squared minus 5x plus 3. Okay, cool. And then I got a g of x, which is 3x plus, and this is where I have this weird k. Okay, cool. So what am I doing with this? Well, okay, so I know I got to find a value for k. I know that's the unknown. I've written this out here. Now, the next key point is this line, right? So what this line is telling you, okay, is that you need to figure out the k value that will make f of x and g of x cross at 1 point. Okay, cool. Now again, what would we do to solve this? Like, say we knew what k was, what would you do? Well, okay, we would do this, right? F of x equals g of x. So let's just do that. And if and now I know I'm kind of playing a game here. I know what's going to happen. But even if I didn't, and you could be in the situation where you may not be sure what is happening, even if I don't know what's going to happen next, I know if I make f of x equal to g of x and just kind of follow the same process we've been doing, like, I think something is going to happen that may spark a moment in my memory that will then kind of unlock the solution to this question and how to solve it. Okay? So let's just write this stuff out nicely. So I have f of x. Okay, so I have 2x squared minus 5x plus 3 equals 3x plus k. Okay. So now what do we do next? Well, next we would move everything on the g of x side to the f of x side. So let's just do that. So I have 2x squared minus 5x. This 3x will become minus 3x. And then plus 3. And then again, this k, which notice doesn't have an x with it, is going to be minus k. And this equals 0. All right. Everybody with me? I'll give you a sec just to let that absorb. So now, again, if we're thinking about it, what do we do? Well, you know, the middle terms, like this, these I can simplify, right? And then these ones I generally could simplify, right? So that means I'm going to get 2x squared minus 5x minus 3x, leaves me with minus 8x's. And 3 minus k, well, I can't do anything with that. This one I can't simplify, so I'm just going to leave it as 3 minus k. All right? So now, what would we do next? Well, if we knew what k was, we would, you know, we would find the point or points of intersection, or see if you know, so we would use the quadratic formula to get our x's and see if there are any. But remember, this question here doesn't want the solution to g of x and f of x. It wants the k value that will make these two cross at exactly 1 point. So what I'm going to do is, well, what do we do in this example to figure out how many times these two things crossed? Well, we just use a discriminant. All right. So here we're going to use the discriminant. All right. But it's going to be equal to 0. Okay. Now, why is it equal to 0? Well, because we want it to cross at 1 point. We want, here, let me scroll it, move that down. Actually, I'm going to move this here, or I'll leave this here, and then I'll write underneath. Right, we want f of x and g of x to cross at 1 point. So that means for them to cross at 1 point, b squared minus 4ac must be equal to 0. All right. So let's do that. So we got a equals b equals c equals. So let's just see what I got. A, so 2. So a is 2. All right. B is minus 8. And then check it out. C is actually, like this whole thing is C. Because again, the K isn't an X. Okay, it doesn't have an X attached to it, so I can't put it with the B value. The K also doesn't have an X squared attached to it, so it can't be part of the A value. So my C value is 3 minus K. And then now, hopefully, you'll kind of notice, if you haven't, like why this is going to help. Because now I have this is an equation that I'm going to be able to solve. All right. So what's B? Minus 8. And then A is 2. And then now C is 3 minus K. And then now we're going to solve this equation for K. So I'm going to get 64 minus 8, 3 minus K equals 0. And then I'll have 64 minus 24 plus 8K equals 0. And then now, so just remember when I'm solving, right? I mean, this is kind of simple, right? Like I have this, the K is here. So like once I figure out what this is, I'll move it across, right? So this is going to be 40 plus 8K equals 0. So then 8K equals minus 40. Divide both sides by 8. So K equals minus 5. Right, so f of x equals, oh gosh, I forgot what this thing, 2 minus 5. And g of x equals will cross at only one point. Okay? So again, we're using the idea of the discriminant to help us kind of reverse engineer the problem, because the first three examples we did today, we were just given two functions and we had to solve the system. Here, we're given one function and then part of another that has a missing piece, but you have enough information in the question to actually solve it. All right. So we have one more to go, and then we're done. Okay. So again, a very similar question. So I'll give you a sec to write it down. Just we use different vocabulary. All right, so again, as you kind of ponder this question, so I have an f of x. So very similar to the last one. Just, we throw in new letters to, I guess, maybe make you a little weary, but no worries. So I have n f of x, which is a quadratic. And if I look at f of x, then f of x looks like it has every part of it. Like there's no missing unknown. But then if I look at g of x is a little different because g of x has the unknown, right? It has m attached to the x. So notice the difference between, see how like the last question, our g of x, which was our linear function, it was like the term with no x. This one now is the term with the x. Now, if you remember from grade 9, and obviously grade 10, because it's something that we generally, if you're taking math consistently, you don't forget, right? When I have the general equation of a line, which is, right, y equals mx plus b, right? The m is the slope of the line. So this question is saying, what values of the slope of the line would make it a tangent to the parabola? So here you have to activate some prior knowledge, okay? So like the question is assuming, and I mean, it's rightful to assume that you know what the slope is. And that you understand that this here, right, like g of x is a linear function that right, where the slope is unknown, but the y-intercept is -2. All right. So we've just kind of activated that memory. All right, so now we know that. Okay, cool. So I know m is the slope, which means that I get this line here, like this. Now make a tangent to a parabola. Well, remember, if I go back, all right, what does tangent mean? Tangent means one point of intersection. All right. So this means one point of intersection. So that means that the discriminant is going to equal 0. Okay. So after we've kind of just debriefed that, I feel actually really calm and chill because, I mean, essentially, this is the same style of question as example 3. It's just that the unknown has been switched to a different part of the linear function. And, this whole thing here, right, has some, like, just has more kind of grade 11 level terminology, okay? So again, the way we attack this question is going to be exactly the same as we attacked all of them. Well, okay, so let's, if we're going to start, then we know, hopefully by now, right, I'm going to make f of x equal to g of x. Okay. And then what's f of x? 3x. So 3x squared plus 4x, or sorry, is it plus? Yeah, sorry, plus 4x minus 2 equals, and then g of x is mx minus 2. All right, so we got that going. So now, same deal, right? All the terms on the g of x side, I'm going to throw across to combine it with f of x. So I have 3x squared and then plus 4x. So notice now, check it out. This, like the mx, see how now it's with this term. So look, this term's a little weird because the last example, it was with the c term. So I have that, and then I have minus 2, and then this minus 2 becomes a plus 2. And this all equals 0, all right? So now, if I look, like, these terms, when I look, I can't, like, we can't just subtract here. Okay, why not? Well, I mean, they're not like terms. Okay, so watch what I'm going to do. Is I'm actually gonna we're gonna factor out. Okay, so we can factor an x, right? So I'll write it like this. All right, so I have 3x squared plus, if I take out an x, what do I have? I have 4 minus m. And then -2 plus 2, well, that's 0. So then I'm just left with that. So what I have, this term, right, a equals 3. And then this thing is the b value. B equals 4 minus m. So now we use the discriminant. Right, so b squared minus 4ac. And again, we're going to set it equal to 0 because, right, in the question, we want it to be a tangent. Okay? All right. So let us do that. So 4 minus m squared minus 4 times 3 times c equals 0. So now what is c? Well, c, like there's no c value, so c equals 0. All right. So then this whole thing, essentially like this part, right? -4 times 3 times 0 is 0. It's going to be wiped out. So then I'm going to have 4 minus m squared equals 0. And then, well, obviously, if we look, right, m equals 4 is the solution to that equation, because 4 minus 4 is 0, and then 0 squared equals 0. And then so f of x, or sorry, let's see. A slope of 4 in g of x will make it a tangent to f of x. Check mark, and we're good. All right. So that was the last example. What I'll do is I will